Good morning, friends. In the last lecture, we had talked about the general notion of production, and we had talked about a generalized model of a production system. Today, we are going to be talking about the life cycle of a production system. As you are aware, the term life cycle implies that a particular system or a particular entity undergoes changes throughout its life, and therefore you can characterize different kinds of performance characteristics of the system at different stages of its life. In this particular lecture, we are going to talk about the various stages of a production system, and we'll see what are the kinds of decisions involved at different stages of the production system. Let's broadly try to recapitulate what we did in the last lecture. We talked about the notion of projects and production, and we tried to distinguish between the two. And in fact, we found that projects and production are interwoven with each other in real life, and even when you are talking about production systems, you have to carry out many projects like improvements or modifications in the system. Then we talked about the general notion of a generalized model of a production system. I think the key thing here was that a production system is not just conversion of raw materials into finished products. It is in fact much more. And we tried to identify some of the other important variables in the context of a production system. And some of these variables, you would recall, were like the notion of a feedback, which was governed to a very large extent by consumer behavior, fluctuating fashions, and things of that kind. And then, of course, the most important variable was the environment with its social, economic, and political components, which would influence the production system to a great extent. Another thing that we saw was that value addition was a central concept in all production systems, and in fact production systems were designed or are designed to basically add value to inputs, and this is therefore something very, very important. We also talked about the notion of inputs, outputs, and the various kinds of transformations. We talked about the challenges in production, primarily with regard to price, quality, delivery time, and various other things coming up as a consequence of global competitiveness. Then we also looked at service systems and saw how they were different from manufacturing systems, and therefore required different kinds of treatment, different kinds of designs, and also different kinds of operation. We then ultimately gave a formal definition of operations management, so on. So with this perspective in mind, let us now talk about the life cycle of a production system. When we talk about the life cycle of a production system, basically we are going to be talking about these four things. We are going to first of all talk about the various stages that are there in the life cycle of a production system. I think it's important for you to understand as to why do we divide the various stages, the various stages in the life of a production system. Why do we divide them into these stages? What is the specific advantage to managers in this division? You know that if you look at it philosophically, science is basically a process of classifying knowledge, isn't it? You talk about the physical sciences, the chemical sciences, you talk about biological sciences, you talk about various other divisions and so on. So classification helps us actually to understand knowledge to a very large extent. And you know, even great poets like Shakespeare have divided the life of a man into 7 stages. And there's a very famous poem called The 7 Stages of Man, where a particular character in Shakespeare's plays describes how a child who is mewling and puking ultimately becomes a lover, and then ultimately becomes an old haggard man and dies. So there are those kinds of classifications there. Even in Hindu mythology or in our ancient scriptures, we essentially talk about 4 stages of life. We talk about childhood, we talk about youth, and after youth we talk about, what else do we talk about after youth? Yes?
Middle age.
Yeah, but middle age, what is the basic idea that you're there?
The householder.
Yeah, you're talking about the householder. You're talking about the householder. That is when a person is looking after the house, he's a gresti in that sense of the term. And finally the sannyasin or the vanprasth, that stage. Now the basic idea behind this division is that at each stage the problems and priorities are different. As a child, you are consuming a lot of butter like Lord Krishna and becoming stronger, playing, and that's the kind of thing where you don't have any responsibilities. So your domain of activity is defined by this thing. When you are a young man entering college, you are more responsible, you have your career to look forward to, and therefore your priorities have changed totally in that system. And then when you are a householder, your priorities are totally different because you are raising a family, you have to look after the family, and that becomes a major priority. And finally, once you are through with these stages, the last stage is supposed to be the stage where you are looking after your own self and trying to discover the reality of life. And to do this, you take renunciation. Renunciation is in the sense that you are basically not bound to the objects of senses in the real sense, and therefore you are contemplating about the reality of life and trying to determine. So this was in some sense a division of the life cycle of a man, and the idea was that you have different stages, and at different stages you are required to do different things. That's the important issue that we're talking about. So similarly, when we're talking about the life cycle of a production system in our context, we are essentially talking about, we'll first talk about the various stages in the life cycle of a production system. We'll talk about the characteristic problems and challenges that arise at each stage. Right? We'll talk about the major managerial decisions to be taken at each stage. And of course, we'll then indicate, once you know the problems, what could be the modeling and solution methodologies that could be adopted for dealing with these kinds of problems. You know, you need a specialist to deal with each problem. If you are dealing with a child, you need a pediatrician to deal with the problem. If you're dealing with an old man, you need a geriatrician to deal with that problem, because so you have entire disciplines based upon these stages. So I think in a similar vein, one can understand that problems of production systems are going to be different at different stages, and we must understand these various stages and see what kinds of problems are there, because this would provide you a perspective of what all is involved in the production system at large. Let's take, for instance, the first stage of the production system, a stage which we say is the birth of the system. And basically, how does a production system take birth? basically the birth of a production system is determined by some crucial management decisions, and these decisions are: number one, what are the corporate goals, and secondly, what product or service you intend to produce. These are the two important things that you're talking about. Now the corporate goals could be entirely different. There could be an organization whose corporate goal is making money. Most of the organizations have this as an objective, if they are making money. So if the objective is to make money, they would probably like to look for a product or a project which would probably give them the best return in terms of whatever they do, and the choice of the product or service is then going to be dependent on this objective. Similarly, there could be other organizations, service organizations, altruistic organizations, which are not interested in making money. I mean, they need money. Every organization would need some money, but their primary goal might be to maybe provide some kind of service, free service to travelers who are traveling to Haridwar, for instance, and you want to open a dharamshala there. Now, if this is a kind of a project or a production system that you want to set up, the goal is entirely different. And for this kind of a goal, the nature of the product, the design of the product, and the kind of service that you want to provide would be entirely different. So one must realize that the birth of the system is something which is intimately linked to the corporate goals. So you have to recognize what your goals are, and based on the goals you have to decide what product or service you would like to produce, and that's the major activity that takes place at the first stage. And in doing this activity, some of the major considerations that management has to go through at this stage are: you have to first of all get future long-term trends of growth of various products. Is it worthwhile for me to enter into cellular phone technology, or is it better for me to enter into maybe some kind of housing projects or whatever it is, those kinds of things. So this kind of a decision is dependent to a very large extent upon what are the future term trends of growth. Growth in terms of which are the new products which are coming on the market, which are the new technologies which are prevalent and which are going to be dominating the scene, how are consumer preference patterns going to change. This is something very important. Consumer preference patterns to a very large extent depend or govern the sales or the demand for any particular product. So unless you are in keeping with the consumer preference patterns, you would not be able to get the wave, and therefore it's very important that you determine consumer preference patterns. The industrial climate, what is it like? What kinds of government policies are in vogue, and what is the trend of the government in future? Which kinds of products and services are likely to be favored, which ones are not likely to be favored? So this decision is not easy, but the basic data you require for doing this is something of this kind, and what you require here is long-term forecasting of different types of products, technologies, customer preference patterns, industrial climate, and all these things before you are able to make a decision. This is how products are growing. The second basic thing that you need in the product is what is the basic desire of the company or the CEO of the company in setting up this project. What is the commitment and what is his experience? For instance, if there is a company in the software business today, it might find that manufacturing in terms of aluminium is picking up in a big way, but the question is that because of its expertise in software, it might not like to go into that particular area, or it might like to go into that particular area. It can pick up specialists in that area and then try to diversify after all. So this question of whether a company would like to diversify or whether a particular company would like to continue and excel in the field in which it has the experience, this itself is a decision, and this will govern whether to set up a new. And of course the third major thing is, what are the available or projected resources? How much money can the company raise for setting up this new product? And when you are talking about raising resources, normally you are talking about not only your own resources, but you are also talking about the amount of resources that you can raise as a consequence of your own reputation. For instance, if I am a pauper and I go to a bank and ask for a loan of 5 crores, they will say get away. However, if I am belong to the Ambani family and I go to a bank and say give me 2 crores, no sir, take 10 crores, the bank will say. So to a very large extent, your capacity to raise funds depends upon your past performance, behavior, and also the reputation in the market to a very large extent. So these are all important considerations when you talk about setting up a new system, and these are the considerations that you will have to be very careful about when you select a new product or service. And I think this is the first stage of setting up the production system, giving birth to the production system. Now suppose at the first stage you have decided that you want to set up a cellular phone technology and you want to compete with Reliance, or you want to compete with Bharti, or you want to compete with any of these cellular phone providers, and you want to set up a new company. The next stage would be a very important stage of what we can call product and process design. So at this particular stage, the issues are really designing of the product or service, and this design has to be based on the technological design of the product. That is, you want to talk about the form and the appearance of the product, and you also want to talk about the process which you are going to use for manufacturing this. So it would involve selection of the appropriate manufacturing technology and the appropriate sequence of operations. Normally the decision comes from the what you have to make and how you have to make it. Depending upon the quantities which you want to produce, depending upon the quality that you would like to have, and depending upon these kinds of important parameters, you can make a choice between the design and the process selection for the new product. Some of the major considerations here are, during the design, what are the major considerations during design of any product? It all begins with customer needs. So you have to establish the need of that particular product and what is likely to be the clientele for that customer. And for this you might have to do very appropriate, very detailed marketing research studies to identify who the customer is, what are his specific needs, how is he geographically distributed in the space, and these kinds of things. And after doing this, you have to talk about the product characteristics. What kinds of materials would you need for the kind of application that you intend the customer to have? Is the product going to be used in a typical Indian kitchen where it is going to be wet all the time, and maybe under such a situation you have to find out what are the appropriate materials that you should be using for that, right? You invariably find that in the kitchen many products that are designed, typically low cost products, they tend to go bad with all kinds of with rough usage and also with exposure to water. They get corroded and so on. So if you are designing a product, you have to talk about behavior of materials in that context. Then you have to talk about the available processes of manufacture for dealing with that particular material, and then you have to be clear about economics. You got to find out, for instance, what is going to be your fixed cost, what is going to be your variable cost for different levels of production, how do you determine a break-even analysis, how do you do the NPV calculations, how do you find out the IRR, and these kinds of things. So they are all relevant, but remember that everything flows down from the customer. And one of the major problems with typically engineering orientation is that people tend to lose sight of the customer, and they keep on refining the product thinking that they have done a very good surface generation using the latest CNC machine, and therefore it's very good, without talking about what the customer is. So in the design methodology these days, we talk about things like QFD, quality function deployment, which means that you talk specifically about customer needs, what he wants, and you translate them to the product specifications systematically, and then design your product keeping those specifications in mind. So these are broadly what happens at the stage of designing the product. During process selection, you have to be aware of the available technologies, and when we talk about these available technologies, we have to also be talking about the economics of these technologies, and we have also to be talking about the required specifications. That means specifications are those specifications that you want the customer to, your product should comply with these specifications so that customer gets the right kind of performance from the product in that sense. So this was a broad idea of what happens at stage 2 in the life cycle of a production system, where we are talking about product design and process design, right? And as it is, as we said, there are specialists in every stage. So you would have specialists of product design, specialists of process design, who would actually be doing these activities for that particular organization. Let us talk about the third stage. Third stage is the design of the system. So far we have talked only about the design of the product and how it is to be made. That was the basic decision involved in stage 2. In stage 3, we want to set up a system which will accomplish what we wanted to do in stage 2. So this is the design of the system. How do you set up the factory? So stage 3, setting up the factory, talks about various crucial decisions. Some of them are facility location. Where should the manufacturing plant be located? Where should the warehouses be located? Where should the retail centers be located? And these are all actually optimization decisions which come under the domain of facility location problems. What should be the physical arrangement to adopt? What we are trying to say here is simply that should we set up an assembly line, and if we set up an assembly line, then there could be various types of configurations we could follow. We could have one machine following the next machine, follow the next machine, all in a straight line, right? This could be done in a straight line. What we mean here is essentially that it could be a situation where it could be this kind of a flow system. The product comes here and you have one machine here, the next machine here, the next machine here, and so on, and the final product comes out here. Of course, you could have variations in the spacing. The same assembly line could also be a U structure, where product flows in the U-shaped thing and ultimately the final product comes out here. Or you could have an L-shaped flow, product flows here. All this could depend upon the constraints on space that you may have. And a U-shaped configuration is obviously more efficient, because Within the same space you have been able to accommodate more machines essentially. So these are decisions which you have to take with regard to the physical arrangements to adopt, and that's what we call essentially a mass production system. We might decide on a process layout or a job shop, which would mean that you could have different departments, and these different departments could be grinding A, B, C, D, E, F, etc. What would happen in a layout of this kind is that a product, you could manufacture a variety of products, and each product would follow its own path through the system. So these kinds of decisions on whether we should have a mass manufacture or whether we should have a process layout or whether we should go for job manufacture, this is what we mean by saying which physical arrangement to adopt. And there are different procedures and different algorithms for designing each of these systems. But at the moment we are merely talking about this decision. So this is it. And then another factor, once you have designed the system, is how to determine the demand for product or service. Suppose you have designed your factory to produce 100 cars a day, but you are not necessarily going to produce 100 cars per day. If your demand for cars on a particular day is 50, the next day 62, third day 150, and so on. So if there is a fluctuating demand for the product, so you would first of all you require a system by means of which you should be able to determine the demand for the product or service, and only when you do this can you actually plan for this variable demand. So the design of the system talks about some of these major issues, and some of the major considerations here as to what you have to do, we have already hinted at some of them. You would normally begin with this stage with surveys and feasibility studies to establish the demand of different products, different technologies, and so on. And then you would work out the economics of different types of production systems, whether you're using mass production or batch production or job production or project production in that sense. I hope you now understand the distinction between job production and project production. Do you? Well, in a project production, the quantity is one-off, and when you are producing just that individual quantity, you have to actually plan out the individual jobs and activities that have to be done to make that particular one-off. For instance, if you are building a flyover at a particular intersection, it's a project. So you will have to decide upon which are the various activities that have to be done, what is the sequence that has to be followed, and then based on that you would determine a schedule which is generally based on a network of when which activity would be done, and determine a critical path and that kind of activity. Whereas in job production you have manufacturing facilities for dealing with a variety of situations, and a job which comes can simply go the way it likes, and it would be quite a chaotic and confusing material flow when you are talking of a job production or even a batch production. However, when you talk about mass production, the flow would be very smooth, right? So these are the kinds of decisions that you would take, and based on the economics and these features you do the layout planning. The layout planning is in terms of determining which kind of system to have and how exactly you are going to lay out your machines and other facilities within the plan. And then you talk about quality assurance. How do you set up procedures for quality assurance? At what stage do you decide to inspect the product or project, and what kind of systems you set up in place? And finally, no design of a factory would be complete without a system of demand forecasting, which will actually tell you what all is to be done, how the demand has been varying, and once you know the variable demand, you should then be able to think of ways of coping with these. So we have come to the end of the third stage of the life cycle of a production system, and basically till now we have not produced a single product, right? We talked about the birth of the system, then we talked about product design and process selection, very important places, and third we are talking about setting up the facility of the factory. So the product has not actually flowed out so far, and this could be considerable lead time there. The fourth stage in this entire exercise is the stage of manning the system, which is a very crucial stage, because if you have now designed the factory, you must know how different operators, how different supervisors are going to man that factory. So you have to work out the requirements of manpower needed at different points within the factory. So some of the major decisions involved in manning the system are: what job is each worker to perform? So this is job design, right? You would know what exactly you are expected to do within the factory. So basically you are designing jobs for everyone who is going to occupy the factory, right from the operator who might be assembling some product on a table, to the security guard who would be manning your gate, to the engineer who would be supervising these various people. So you know exactly what each person is supposed to perform. So this is the crucial stage of what we call manning the system. Then once you have designed the job for each worker, you have to worry about how will the job be performed. After all, even if there is an operator who has to take up some raw material from here, pick up some other raw material from here, assemble the two things, and then maybe put the finished product here, there could be various ways in which this could be done. And especially as your system is concerned, you have to standardize the method by which this process has to take place. And as you know, when we are talking about systems like ISO 9000, the basic job of ISO 9000 is to specify or write down exactly how the process performs from which stage to what stage and what different people are supposed to do. So unless you document that, that's the first step towards quality. Okay. So how will the job be performed? You are probably aware of a discipline known as method study, which is a part of industrial engineering, in which you establish the best method for doing a job, which means you would specify a thing like this: the person picks up something with the left hand, he picks up a nut with the right hand, he assembles the nut, then he tightens it with the right hand and places the whole thing, the assembly, on the bin available on the right side. This is the specification of a method. You could actually be experimenting with different methods and finding out what are the times and the worker fatigue that they lead to, and then specify an ideal method for doing each job. Okay, that's what we mean by method study and ways of doing the job. So this is what is implied here. Okay, so how will a job be performed? That is method study. How will it be measured? We talk about primarily work measurement, where we are talking about time studies, establishment of the time that you observe and the allowances that are there, the rating for the operator, and then you specify a standard time for each operation. This is very important because based upon the standard times of each operations, can you actually determine the rated capacity of a manufacturing plant. Okay. So this issue of determining this is basically the domain of work measurement. And then a very tricky issue for workers is how will workers be compensated? If we have designed a certain specific method and given the workers a specific time, according to that, suppose he is required to make 50 pieces per day of a certain assembly, which is subsequently used in the major assembly. What would happen if he makes, instead of 50 pieces, 75 pieces on a particular day? How will you compensate him? Will you compensate him or will you not compensate him? Obviously he would expect some compensation, because you know that there is a heavy union behind things, and this is one of the very tricky issues involved. So you have to develop what are known as wage incentive schemes. What kinds of incentives will be given to workers if they perform at a particular level, and so on. So all this domain of dealing with the human being in the context of the production system, which is in fact extremely important. This often leads to the difference between a successful manager and an unsuccessful manager in a company is primarily because he is not able to handle his workforce properly. So apart from other decisions or other qualities like leadership, motivation, an MBA degree from Harvard and these kinds of things which are involved, what is really more important is a true understanding of the problems of the workers and an ability to sympathize with them, but at the same time communicate to them what is expected from them, and they are paid accordingly. So this is the stage of the manning of the system. So this is stage 4, where we are talking about many of these problems which would occur here, and of course we have summarized most of these major considerations, where work measurement is important, setting of production standards is important, designing of wage incentives is important, the determination of the capacity of the plant is actually a natural corollary of this particular calculation, and planning resource acquisitions. These are the kinds of decisions, managerial decisions, which are involved at this stage of manning the plant in that sense. Yes, let us now go over to stage 5. Up to stage 4, as I said, our factory has not produced anything. We were designing the factory, it took time to set up the factory and so on. This is the stage when actually things start moving, and we are talking here about startup of the system. This stage is the startup of the system. Normally this would be the stage where your factory is ready and you are about to give out the first product, and you are probably called a chief minister or the prime minister to come and inaugurate the plant for you. So it's at that stage that we're talking about, when the plant is ready. At this stage, generally there are two major concerns for management. The first major concern is talking about the initial problems. There are always some initial problems when you set up a new system. Okay? You may have noticed that when you buy a new computer or you are trying to set up something, there are always some problems. So either you have to call the installation guy, or you got to call a friend who is an expert at installation, who will get you out of these problems in the new system also. So there are always some initial problems. And the second issue that we are talking about in startup is that how much time will it take to reach the desired state. You see, it's a very simple thing. What happens invariably is that your plant is designed for a certain capacity. Let's say this is the capacity, right? When you start production, your capacity doesn't suddenly reach this original value. So it might be something like this, or it could be something like this, or it could be something like this, whatever it is. So what we are talking about is this time. This is the time required to reach the desired production capacity. And you have probably heard that most companies open up in phases. I mean, they don't reach the whole thing. So this amount of time, this is what we are saying, how long will it take to reach the desired state? This is important because this has economic implications. The sooner you start producing more, the higher would be the NPV of returns, and therefore you are very keen to minimize this particular time, in that sense. So some of the problems that occur at this stage are problems of installation. You have installed a new machine, so at the time of installation there are some problems. Either it is not fully operational and therefore you have various, the person whom you have called for installation will have to look into it, and probably there is a faulty connection or something like that. These kinds of problems arise. Another major problem that arises at this stage is training of personnel. Okay. So we see that in the stage 5, the problems could be of installation on the one hand, training of personnel could be another problem, coordination could be a third major problem, and the learning phase is of course an important thing. The learning phase is when you are introduced to a new system, it takes time for you to understand the new system, and therefore there is this problem of learning at the initial stage. So training, learning, coordination, so that the various problems are sorted out to some extent, could be there at this particular stage. These are the problems associated with startup of the problem. That means if you want to get the factory into operation, typically you would encounter these kinds of problems. The next stage, or the 6th stage of the system, is when the system goes to the steady state. In fact, most of you young engineers join a factory or a production system which is already in the steady state. So you might continue to work in the system in the steady state and never get an opportunity to see any of the problems that we have talked about, right? Because you spend a lifetime only in the system in the steady state. So in that sense, most of you who join companies which are running, what do? What are the kinds of problems, or what are the kinds of decisions that managers have to take in that context? The major problem is how to run the system. So you have to first learn how to run the system. Which are the major things? Which are the raw material suppliers? How do you place orders with them? And you've got to be clear about all the procedures which are to be followed there. So most of the people spend their life doing that. How to improve the system is another thing. For instance, if you are an enthusiastic engineer and you join a company, and you join the company maybe to find out that every day there are lots of accidents taking place at a certain location because oil is dripping from a certain overhead conveyor, right? And every day you find that 1 or 2 workers slip, trolleys slip, there are accidents. So what do? When the system is in steady state, you have an opportunity to improve the system by maybe changing the conveyor or trying to put a better design so that there is no leakage and to prevent accidents. So this is an instance of what we mean by improving the system. So most young engineers, when they join companies, after they have learned to run the system, would be actually improving the system by using their creativity at different places in the system, or suggesting some improved design of something, things of that kind. And of course, the major thing here is how to deal with day-to-day problems. Day-to-day problems meaning that the problems of actually running the system. So you are all the time concerned about things like running after your suppliers, phoning up a particular vendor, and trying to get the materials on time, or if there are complaints, then you are lodging complaints most of the time and doing this. These are typical day-to-day problems. So you are really in this domain of the system in the steady state involved with these kinds of problems, and when you are doing these problems, you can be helped with things like statistical quality control to maintain quality and doing the various things. So some of the major decisions here are day-to-day, setting production targets every day. A setting of production targets depends upon the demand, which you probably have a forecasting system, and it also depends upon the capacity that you have available. Then you are dealing with decisions like scheduling, sequencing of jobs. A number of jobs are to be done within the factory. How do you schedule them? That means which job to be done when, and what is the sequence in which these jobs to be done. This is a very fertile area for mathematicians, right? So you can use lot of models, lot of heuristics which will help you come here. Similarly, inventory control. You would like to minimize the amount of inventory that you have at the raw material stage, at the finished goods stage, and also in process. So you can talk about what should be the realistic ways of setting your production batches or procurement quantities. You can use economic order quantities and so on. So you have a lot of so you find that lot of mathematical models, tools are available for dealing with the day-to-day decisions which are required. For quality control is another area. You can maintain control charts, you can try to determine what exactly has to be done, and keep on doing these various things. And then we talk about production control. Production control is actually the activity where you are trying to ensure that your operation is as per the target, essentially that's what it is. Similarly, cost control, and then similarly maintenance, which is a major activity at this stage, because when a plant is running, maintenance is a major activity. And in maintenance you are talking about whether it should be predictive maintenance or whether it should be preventive maintenance, whether you are going to do condition monitoring of jobs and crucial machines to determine the optimal frequency of opening up something. So these are some of the major decisions which are involved at this stage, the sixth stage of the production system. Stage 8 of the production system, sorry, the stage 7 of the production system is what we call a revision of the system. Revision of the system, the decision here is how do you revise the system in the light of external changes. We had seen that even when the system is running in its steady state, there are small suggestions which you can do for improvement. Revision is not that. Revision is doing something totally different. The kinds of changes that we were talking about in the steady state were actually Kaizen or day-to-day improvements. Here we are talking about BPR, business process reengineering. We are talking about some significant changes on how to revise the system in the light of external changes. Okay. What might happen, for instance, here is that if you take a company like ITI, Indian Telephone Industries, previously it was making only the conventional landline phones, but then it saw that the market for cellular phones was really growing, and this could be perceived as a threat to the company. So what would the company do? One option could be that it would continue to specialize in these very landline phones, and die a natural death, as the case may be, or it could diversify and try to make cellular phones also along with the system and do both these kinds of things. That's what we mean by system revision in that context of the term. Okay. The important thing to note here is that companies which don't make these decisions often die. For instance, the Swiss watch industry, famous for its watches, is now gradually dying a death because there are very good electronic watches available, very cheap, Japanese, Seiko and others, which do all the jobs, and you don't have to. So that's a situation where they have not revised the system. Of course, there could be an advantage in antiquity. I mean, you can become antique and therefore sell your products at any price. But the final stage, I mean, when we are talking about this seventh stage, we have therefore to talk about issues like technological threats and opportunities, revision of market demand, newer products, technological innovations, and newer methods of manufacture. All these have to be considered when you are thinking in terms of revising the system and doing this. The final stage of the life cycle is the stage 8, which is the termination of the system. At every stage, any factory or anything has to be dumped. So here again, the difference is very obvious in the sense that just as in a human being, you don't decide when you're going to die. The Lord Almighty will probably one day decide suddenly to pick you up, and that's the end of your life. But in the case of a manufacturing system, how does a system die is a managerial decision. And what can be done to salvage resources is also a managerial decision. And when we are saying how a system dies, the way of dying could be, these are different ways of dying. You could think in terms of a manner of phase out, that over the next 2 years we are going to phase out this product and therefore the system will die. And you can work out the economics of this and do it. The second thing could be, it could be a total sellout to another company or a merger with another company. Campa Cola of India died by a merger with Coca-Cola. It was an economic decision based on the part of the CEO of that company. Or you start a new product in that same thing, so the old product automatically dies. So in that sense, remember that even the death of the system is basically an economic decision, and you have to work out what is the best way of dying for the manufacturing system and adopt that kind of thing. Finally, I would just like to summarize what we have tried to talk about in this particular session. We have first of all looked at the various stages in the life of a production system, and we have identified 8 different stages, and we have tried to identify the characteristic problems and challenges which arise at every stage, so that you know that at this particular stage these are the kinds of decisions and problems that you would be facing. We have seen what are the major managerial decisions to be taken at each stage. And basically this course of production management is a study of these managerial decisions to be taken at different stages in that sense. And what helps you take these decisions is that there is modeling and solution methodologies available for modeling the problems at different stages and also developing solutions for these various kinds of problems. In our next lecture, we will try to have a glimpse of the role of models in production management and see how different kinds of models could be helpful for different kinds of production systems. Thank you.